Okay, in this question, we are given that A and B are events with probability of A is 0.02, which is 2%. Probability of B is 0.25, which is 25%. And that probability of A and B is 0.005, which is the same as 0.05%. Now we have four questions. The first one is, are these two events independent? The second and third questions are about conditional probability. And the fourth question is about probability of A or B. So it's an or probability here. So let's solve them one by one. The first one is, are these two events independent? So you should ask yourself first, when are two events independent? So we know that A and B are independent if the rule is the probability of A and B should be the same as the probability of A multiplied by the probability of B. This is the rule, that if it is true, then they are independent. If these two numbers are not equal, then they are not independent, or you can say dependent. So let's check. Probability of A and B is given to us already. It's given here. It's 0.005. So this, we have computed the first part of this equation to check if they're equal. Now probability of A multiplied by the probability of B is equal to probability of A, remember, it's 0.02 multiplied by the probability of B, which is 0.25. And if you do this on your calculator, you will actually get 0.005. And notice that the number that you got here, probability of A and B, is the same as the multiplication of the two. So these two numbers are equal numbers, and so this is true here. So you can say, therefore, A and B are independent events. Independent events. And you can answer the question. This question, the answer is yes. Okay, so this is the first part of this question. Now the second part is find the conditional probability of A given B, which we write like this: probability of A, then a vertical line B, but you read it probability of A given B, or you say probability of A happening given that B has occurred already. So we have a rule for this. We have that the probability of A and B, I will remind you of this. In general, this here is in general. It is probability of A times probability of B given A, and at the same time you can write it as the probability of B times the probability of A given B. But in this case, you can say that we already know, we know from part 1 of this question that A and B are independent, and so the probability of A given B, the one that they're asking you to find here up, look at what they're asking you to find, we know that they are independent already, so meaning that if B happens, it will not affect A. So this should be the same as the probability of A, which is 0.02. So because they are independent, I need to highlight this. Independent, then this is always true. And also probability of B given A will be the probability of B. But you can also think of it differently. So let me just highlight another way. You can say that, let me use this rule. This is the general rule for the probability of AND. When you don't know if they are dependent or independent, but you're just given numbers. Suppose that you are given these numbers and you didn't check that they are dependent or independent yet. So you can say that probability of A given B, using this rule, the one that I just highlighted, just divide both sides by probability of B, and so you'll get probability of A and B divided by the probability of B. And we are given that probability of A and B is 0.005 divided by probability of B, which is 0.25 given. And if you do this calculation, you'll get 0.02, which you expected. This is the same as the probability of A, because A and B are independent. We showed it in part 1. And if you see, I already told you here that because they are independent, you can conclude immediately that the probability of A given B is the same as the probability of A. But if you are not given that they're independent and you don't want to calculate whether they're independent or not, you can just use the formula here. One way to remember this formula is that probability of A given B, the B will be the one down, okay? But up always probability of A and B, and then you divide by the one that is second here. So the third one actually is the same question. Probability of B given A. If you want, we can use we can ignore or pretend that we don't know that they're independent. Let's say that we don't know they're independent from part 1. So we use the formula. It's probability of A and B divided by, now it's divided by probability of A. As I told you, you divide by probability of the one that you have here. Then you divide by its probability here. So if you do this, you'll get probability of A and B is 0.005 divided by probability of A given, it's 0.02. And if you do it, you'll get exactly 0.25 on your calculator. But this is not just any number. It's actually the same as probability of B. So let's say that this is the question that you answered without doing part 1 of this exercise. You have shown that the probability of B given A is the same as the probability of B. You can say, therefore, probability of B given A is the same as the probability of B, which implies that A and B are independent events. Independent events. But remember, this rule is not true if they are not independent. Only if they are independent you can conclude this immediately. Okay? So we calculated and we checked that probability of B given A didn't change the probability of B, so they are independent. This is another way of saying that they are independent. So now let's go to the last part. It's number 4. What is the probability of A or B? So the probability of A or, we write it like this, or B is equal to, there is a rule for it, you add the probabilities, probability of A plus probability of B, and then you subtract the probability of the intersection if there is an intersection between A and B. And in this case, they are giving you that probability of A and B is not 0. It is a number. So this means that we just use the formula here, 0.02 for probability of A plus 0.25 minus 0.005. And if you compute this on your calculator, you'll get 0.265. Okay, so this is the answer to this, which is, if you want it as a percent, it's 26.5%. So I want you just to understand the picture now. So A and B, in this case, because the probability of A and B is not zero, you can conclude that A and B have an intersection. So this is A and this is B, and there is some intersection between the two. Some intersection here. This is what we call A and B. And because there is an intersection, you can say that this means that A and B are not mutually exclusive. Mutually exclusive events. You could ask, when are they mutually exclusive? I will just tell you here. Mutually exclusive means that A and B are separate from each other. They don't have any intersection. So this is why some people, instead of saying mutually exclusive, they say disjoint events. And in this case, no intersection. So A intersection B is nothing. It's the empty set. And this means that the probability of A and B must be zero in this case. So mutually exclusive implies that the probability of A and B must be zero. And that's why, let me just find the place to write it. That's why here I will tell you, if they are mutually exclusive, so if A and B are mutually exclusive, then you know the probability of A or B is going to be very easy to calculate. It's probability of A plus probability of B, and you don't need to subtract this because it's already zero. The probability of A and B already is zero, so the rule becomes just here, just this one. So don't confuse the rule here with the rule here. They are used in different situations. If the two events are already mutually exclusive, meaning that the intersection is empty or the probability of the intersection is zero, then you can use the easier version of the formula for OR. But if, as you saw in this example at the beginning, we said that probability of A and B is a number, so it's not zero. So that's why we used the full formula for the OR probability, which is you add the probabilities and then subtract the probability of the intersection, or the probability of A and B. And this will end this question.